Hello everyone, this is S.Harsha and I am from GOUD Institute of Engineering and Technology. My group mates are S.RAJU and S.JAHANGEER and our mentor is A. Ushasri ma'am. My project title is Log Periodic Dipole Antenna with Koch Fractal. Now let's start with our introduction. Antennas are the connections between the space and transmitter or receiver by receptions. Antenna converts electrical signal into electromagnetic signals and it is also used to receive electromagnetic signal. Wideband wireless communications, which low power level and high data rate transmissions, propelled great interest for research wireless communication applications. High performance wideband antennas need for both good impedance matching and low signal distortion within the specified frequency bands. Antennas are used to transmitting signals in omnidirections. They are used in sometimes point-to-point communication without increasing gain. Bandwidth can be increased by changing the number of dipoles. This property makes way for good wideband applications. However, larger in size is the problem of this kind of antenna with the length of 3 guided wavelengths at the frequency that works at lowest. Within ultra-wide frequency band, PLPDA also spreads in end-fire direction. Bandwidth can be enhanced by increasing the number of dipole elements with the multiple resonant property. Antennas are the devices used to send information in the form of electromagnetic wave signals to communicate wireless. The antenna used mostly for radio and satellite TV signals and mobile communications. This is our literature survey. On the FR4 substrate, a printed log periodic dipole antenna with a Koch fractal antenna functions between 2.77 GHz to 3.94 GHz and 9.44 GHz to 10.25 GHz. The main advantage of this antenna are they are compact in size and have good bandwidth. In future, it will be beneficial for a variety of uses including X-band and Ku band applications which are mostly used for satellite and military applications. When using an FR4 substrate, a printed log periodic antenna with a Koch fractal antenna operates between 2.77 GHz to 3.94 GHz, 4.69 GHz to 6.25 GHz, and 9.44 GHz to 10.25 GHz. When we compare with other materials like an RT5880 substrate, it operates between 2.81 GHz to 4.56 GHz, 6.19 GHz to 9.19 GHz, and 11.81 GHz to 14 GHz. These are good for transmitting information from space to other antennas. They are mainly used in military applications and satellite applications. Consequently, they can be adapted in various applications like X-band, K-band, Ku band, and C-band. It can be simulated on HFSS software, but mainly designing Koch fractal antenna for the log periodic dipole using the specified parameters experimentally. HFSS stands for High Frequency Structure Simulator Software. HFSS software has been used to analyze the performance of designed antennas such as return loss, radiation pattern, current distribution, and gain. Advantages of these antennas are that they are compact in size and broad in bandwidth. The antenna is used mostly for radio, satellite, TV signals, and mobile communications. Antennas are used to transmit signals in omnidirections. PLPKDA on different materials are tested and noticed that a consistent performance is demonstrated by the RT5880 material, which is able to resonate from 2.88 GHz to 4.91 GHz, 7.07 GHz to 8.27 GHz, and 10.68 GHz to 13.04 GHz for PLPKDA. Now let's see the results. Return loss. Return loss is a percentage of a signal that is reflected because of an impedance mismatch. It measures the decibel difference between incident power and the reflected power. VSWR. VSWR stands for voltage standing wave ratio. It speaks of the ratio of the transmission line's highest voltage to its lowest voltage. The voltage in a perfect system is constant, hence its VSWR is 1.0. The ratio of the highest voltage to the lowest voltage along the transmission line is what is meant by this term. The voltage is constant in a perfect system. Gain. The amount of power transmitted per solid angle is referred to as gain. For any application, each antenna's gain is larger than 3 dB. Radiation pattern refers to the power variation an antenna emits as a function of direction and proximity to the antenna. This power change is noticed as an effect of the arrival angle in the antenna's far field. These are our experimental values. Now, conclusion. These antennas are superior to typical log periodic antennas in terms of other small size and wide bandwidth. The Koch fractal antenna get gain more than the log periodic antenna. The return loss of also decreasing comparing with log periodic dipole antenna with FR4 and Koch fractal antenna. Main advantage of the Koch fractal antenna is that it operates different type of frequency for required applications. This paper describes the optimization of the structure of log periodic dipole antenna to log periodic dipole with Koch fractal antenna using FR4 material. The gain has raised from 3.1 dB to 6.4 dB, high return loss and stable VSWR. Whereas PLPKDA has exhibited multiband performance in this chapter. A wideband compact log periodic antenna for 10 elements is presented. The work is extended to Koch fractal first iteration log periodic antenna for 10 elements. The performance of the compact Koch fractal log periodic antenna and the compact log periodic antenna is observed for two different types of materials. The gain of Koch fractal antenna on the FR4 substrate is 4.07 dB and the return loss of the Koch fractal antenna on FR4 substrate is minus 36.57 dB. The planned antennas are constructed and properties including return loss, VSWR, radiation pattern and gain are measured to confirm their performance. These antennas are superior to typical log periodic antennas in terms of their small size and wide bandwidth. The Koch fractal antenna get gain more than the log periodic antenna.